Okay. Again come back to the generator power limits, right. So, in this case a little bit you have to understand, because when you solve the problem you will know this. This is ICs. Now we have taken the straight line one, because quadratic cost characteristic. So, this is say IC1, this is your minimum limit, lower limit, say if it is Pg1 max, this one actually Pg1 mean. I have not written here, but understandable that this is Pg1 mean. Similarly, if this is another IC, if it is Pg2 max, then this is your Pg2 mean, right. And this is, if this is for IC3, the for generator 3, that incremental cost 3, if it is upper limit here it is Pg3 max, then here it will lower limit will be Pg3 mean. Now, the generators actually all have to operate on your what you call that equal lambda basis, right. Suppose here it is given some value, this is incremental cost lambda, suppose some value lambda 1 here, right. So, in this case all the generators will what you call will work on this your what you call on this basis, right, equal lambda basis. Now, this is your PGI, this side is the PGI, that your what you call that power generation for the ith unit, right. Now, question is that your suppose your load is increasing, that generator power will increase, that means this lambda line they will operate on equal lambda, you slide it upwards, right. So, when it will come at that after some value of lambda 2, when it will come here some value of lambda 2, that it will touch the upper limit of the your generator 3, that is your Pg3 max, right. So, once it touches that limit, right, so at that time you have to set the generation, that is your what you call Pg3 is equal to Pg3 max, there is no further increase, you cannot do that, this is the maximum limit. Again if you move upwards, suppose load further has increased, for example load further has increased, suppose this is lambda 3, at that time these two generating unit 1 and 2 generation will change, but this one will be kept fixed at this value, right, because it cannot increase. Now, at that time these two units will operate on equal lambda basis, for example lambda 3 equal lambda basis, right. So, again load is increasing, again this line you move upwards, right, finally it will come here Pg2 max. So, at that time it is lambda 4, right. So, at this point Pg2 has to be set at Pg2 max, right. So, and if load further is increased, then if further is increased only this unit will take it till it reaches to its maximum value, right. I hope you have understood this. That means that these are the lower limit, they will operate at equal lambda basis. Now, if load is increasing, generator has to increase, so lambda, so move upwards. So, when it is going to touching the limit of the first, that is the unit 3 maximum, right. So, beyond that if the load further increase, then what will happen, these two unit at that time operate at equal lambda basis, but this one value Pg3 must be kept at Pg3 max, right. Then till load is increasing and increasing, then it will touch here at lambda your lambda 4, that is Pg2 max, right. There also you have to set Pg2 is equal to Pg2 max. After that if load further increase, that only this unit has to take care of the load till it reaches to its Pg1 is equal to Pg1 max value, right. That means in general if total your what you call that your loss is ignored, then maximum load it can take Pg1 max plus Pg2 max plus Pg3 max, this is the total maximum generation is equal to total load, right, not more than that, right. Loss is neglected, remember loss is neglected, right. So, this part this is now this is understandable to you, right. So, that is why this is your figure 5, whatever I have said, all these things actually have been explained here. So, I am not repeating this, right. So, whatever I have said you might have understood, right. So, if you have this thing you can read it once again, but this is the thing I have written here, but I have explained everything, right. So, next is we will take another example, example 2, right, and just try to understand. So, suppose incremental fuel cost rupees per megawatt hour for a power plant considering two generating units are given below. DC1 upon dPg1 is equal to 0.18 Pg1 plus 41 and DC2 upon dPg2 is given 0.36 Pg2 plus 32, right. So, and generator limits are given for these two units, that is Pg1 minimum generation is 32 megawatt, maximum 180 megawatt and Pg2 minimum is 22 megawatt, maximum 132 megawatt. That means, minimum load will be 32 plus 22, right. If you take that your what you call, that is Pg1 plus Pg2 total minimum generation 32 plus 22, right. If both operates together, right. So, that we will see later, and this is maximum 180 and 130. So, maximum is 180 130 means 310 megawatt, right. So, that means this generator can supply 310 megawatt load, right, and this one we will see minimum side how it can operate. Now, you have to determine Pg1, Pg2 and values of lambda for the variation of load from 54 megawatt to 310 megawatt, right. Assume that both generating units are operating at all the times, right. So, you have to find out Pg1 and Pg2 and lambda variation for different and load varying from 54 to 310 megawatt, 32 plus 22 54. So, minimum load is taken here, given the data given 54 megawatt, right. Now, how to do this? You given that Pg1 min is equal to 32 megawatt, right. This is given, Pg1 max is given 180 megawatt, right. So, lambda 1 is equal to DC1 for unit 1, DC1 dPg1, that is 0.18 Pg1 plus 41. This lambda 1 lambda 2 is given actually. This is lambda 1, this is lambda 2, these two data are given, right. Therefore, this lambda 1 is equal to DC1 upon dPg1, that is 0.18 Pg1 plus 41 at Pg1 is equal to Pg1 mean when generating at its lower limit, that is 32 megawatt, right. That means, your lambda 1 is equal to lambda 1 mean, that you substitute Pg1 is equal to Pg1 mean here, right. Therefore, it is 0.18 Pg1 mean plus 41, right, and Pg1 mean is equal to 32 megawatt, you substitute here 32, then lambda 1 is equal to lambda 1 mean, you will get rupees 46.76 per megawatt hour, right. This is lambda 1 mean is for unit 1 rupees 46.76 per megawatt hour, this is for unit 1, then now maximum value. Now, when Pg1 is equal to Pg1 max, it is 180 megawatt. Now, therefore, lambda 1 is equal to lambda 1 max is equal to 0.18 Pg1 max, here you substitute Pg1 is equal to Pg1 max, right. So, plus 41, therefore, lambda 1 your Pg1 max is 180 megawatt. So, substitute here 180, you will get lambda 1 is equal to lambda 1 max is equal to rupees 73.4 per megawatt hour, right. That means, lambda 1 mean we got 46.76 and lambda 1 max 73.4, within this lambda will vary. Similarly, for the unit 2, Pg2 mean is equal to 22 megawatt and Pg2 max 130 megawatt. Therefore, lambda 2 is equal to this one DC2 dPg2 is equal to 0.36 Pg2 plus 32. Now, first you put your lambda 2, your Pg2 is equal to Pg2 mean in this equation. So, lambda 2 is equal to lambda 2 mean is equal to 0.36 Pg2 mean plus 32 and Pg2 mean is 22 megawatt. So, if you substitute here 22, you will get lambda 2 is equal to lambda 2 mean, it is rupees 39.92 per megawatt hour, right. This is lambda 2 mean. Similarly, in this expression you put your what you call lambda 2 is equal to your this thing Pg2 is equal to Pg2 max here, right. If you do so, then lambda 2 is equal to lambda 2 max will be 0.36 Pg2 max plus 32, right. Therefore, lambda 2 is equal to lambda 2 max is equal to 0.36 into 130 plus 32, will get lambda 2 is equal to lambda 2 max, that is rupees 78.8 per megawatt hour, right. So, at the that means at the bottom point, that means look, now we have drawn IC1 IC2 two curves, right. This is for IC1 and this is for IC2, right. So, IC2 actually your this is Pg2 your what you call mean, that is your 22 megawatt at this point, 22 megawatt I have written here, right, and here it is 39.92 almost 40. So, it is starting from here, right, and its max value, that is your what you call IC2's max value, this is your 130 megawatt, right, 130 megawatt, and its max value here is IC2, it is 78.8, right, almost nearly 80, right, 78.8 lambda value, this side is lambda, this side is lambda, right. And similarly for your PG1 mean it is 30 megawatt, 32 megawatt. So, it is near 30, that is 32 megawatt, and its minimum lambda value is 46.76. So, here it is starting from here, and its maximum is PG1 max 180 megawatt, it is going up to this, and according to its graph it is 73.4, this lambda value is, this point is say 73.4. This way IC1, IC2 are plotted, right, and this is your, and PG1 mean is shown, right, PG1 mean is shown, PG2 mean is also shown, PG1 max is here, PG2 max is here, and lambda values minimum and maximum values are computed. Accordingly, these two your IC curves are this is straight line actually, this is drawn. So, this side is the total out, this side is the output power megawatt, this side is the output power megawatt, and this is lambda, and this is incremental cost curves, right. So, I repeat, this is your PG2 is equal to PG2 mean 22 megawatt, this corresponding lambda value is we got 39.92, we got it, right, and PG2 when it is PG2 is equal to your what you call PG2 max 130 megawatt, right, 32 we got, that value is lambda is 78 point your what you call 8. So, accordingly it is a straight line joining. So, automatically you can just join these 2 points, right. So, here when it is PG2 is equal to 22, lambda is equal to 39.1 point, when it is 130 that is it is 78.8 another point. So, you can make it. Similarly, for IC1 when PG1 is equal to 32, you know lambda is equal to 46.76, and when it is 180 you know it is 73.4. So, these two you join it. So, you get this line. So, this is that IC1 IC2 characteristic, this is the first thing, right. So, this you have to make it, right. Once you have done, right, once you have done, so now look at that how we will do it. Therefore, PG1 is fixed at 32 megawatt and PG2 is fixed at 22 megawatt. Total load is 32 plus 22, that is 54 megawatt. Load will vary, it is given 54 to 310 megawatt, right. Now, look, lambda 1 minimum is equal to 46.76 and lambda 2 minimum is 39.92, that means lambda 2 minimum actually is less than lambda 1 mean, right. That means, therefore, as the plant load increases beyond 54 megawatt, the load increment will taken up by generator 2 till both units have lambda is equal to 46.76. That means, this one your what you call this is your IC2 and this is your IC1, right, and lowest value is 39.92. If you increase the lambda value upwards, right, lambda value upwards, that in that case what will happen, that your this till it comes to 46.76. that means your what you call this as the plant load increases beyond 54 megawatt, I mean if total is 54 megawatt, the load increment will be taken up by generator 2, that means this one will be taken up by generator 2, right, till both have lambda is equal to 46.76 when it will come here, right. So, this way your what you call this IC2 is equal to 39 point your this lowest one is 39.92 for IC2, right. So, at that time if you increase the lambda unless until it comes here, right. So, your what you call that that load increment will be taken up by generator 2 till both have equal lambda, that is 46.76. That means, what will happen, that at lambda is equal to your this lambda, hold on, this lambda is equal to lambda 2 is equal to 46.7, when lambda is equal to lambda 2 46.76, that means your 0.36 PG2 that plus 32 is equal to 46.76. That means, this your IC2, this characteristic IC2, right, it is 0.36 PG2 plus 32, this is lambda. So, when lambda is equal to 46.76, right. So, 0.36 PG2 plus 32 is equal to 46.76, therefore, PG2 will become 41 megawatt, right. that means at lambda is equal to lambda 1 lambda 2 46.76 PL will be 73 megawatt. That means, when these two lambdas are equal, when lambda is equal to lambda 1 is equal to lambda 2, because if you see that this is Pg2 41, right, but Pg1, if you look at that, Pg1 minimum is 32, because it is coming here, right. That means, it will come up to this one, right. Therefore, this your Pg2 is 41 megawatt, that means, and at that time Pg1 at its your minimum value 32 megawatt, at that time it is 46.76. Therefore, at lambda is equal to lambda 1 lambda 2 46.76, that means PL is equal to 32 plus 41, that is 73 megawatt. That means, your for lambda greater than equal to 39.92, that means this value 39.92 this value, and less than is equal to 46.76, right, lambda is equal to 40.36 Pg2 plus your 32, because that unless and until it comes here, this lambda 2, this if you increase this one, it is not coming up to this. That means, this Pg2, that is your generator 2, it has to take this load, right, till it comes 46.7, because it is equal lambda basis. So, if you move it up, unless and until lambda comes to 46.76, this IC2 only has to generate this power, because this one is fixed at that time 32, your what you call 32 megawatt. So, in this case what will happen, that 39 the lambda lying in between 39.92 and 46.76. So, lambda is equal to 0.36 Pg2 plus 32, right. So, that means, that Pg2 plus Pg1 mean is total load, that means, Pg2 is equal to PL minus 32, that means, your what you call, that means, your this thing, your Pg1 mean is 32. So, Pg2 is equal to PL minus 32. Therefore, this Pg2 you substitute here, this Pg2 you substitute here. If you do so, you will get lambda is equal to 0.36 PL plus 20.48. This is equation 3. So, this equation 3 is valid for PL greater than is equal to 54, less than is equal to 73. That means, this is valid when this load is lying, this is the minimum load, and this is your less than equal to 73. That means, because total load is 73. So, what we are doing is Pg2 plus Pg1 mean is total load PL, that means, Pg2 is equal to PL minus 32, right. That means, your this Pg2 you substitute here, Pg2 you substitute here. If you do so, you will get that your what you call lambda is equal to this one. So, this equation is valid when PL is lying in between minimum load 54 and then 73 megawatt up to equal lambda basis when it is 46.76. So, I told you that regarding the limit, as long as limit is your what you call, start this example is starting from the lower limit, right. So, this is your IC1, this is your IC2, unless and until it comes to this point, right, unless and until it comes to this point, right, your what you call this IC2 has to your IC or this your IC2 has to take the care of that your increase of load till they come to the equal lambda, right. So, up to 46 points, because here it is pegged at your 32 megawatt minimum for IC or what you call for IC1, right. So, that is why this is for this load. Next, when load is increased beyond 73, right, then what will happen? Just hold on. Now, therefore, Pg1 is fixed at 32 megawatt and Pg2 is fixed your, just hold on, your this is your just 1 minute. Next is load sharing beyond this, point lambda, when lambda greater than 46.76, when it is beyond this is carried out on equal lambda basis, right, till generator 1 reaches its upper limit of 180 megawatt. That means, when now up to this it has come on equal lambda basis, that is 46, till you can increase the lambda when it is coming up to this IC1 is 180 megawatt, and at that time this lambda value, that is your lambda 1 for this one, max value lambda 1 is 73.4, because you this line, this lambda line you are moving up, right, till, because if you increase if you it moves up, then when it will be 73.4 for this one, this will reach at its maximum, that is 180 megawatt. So, that means that that is, and you have to carry out on equal lambda basis, we have seen, right. So, generator 1 reaches its maximum of 180 megawatt, that means Pg1 is equal to Pg1 max, that is 180 megawatt. At that time lambda 1 max we computed 73.4, right. Therefore, that in between 46.76 and 73 point, so in between 46.76 and 73.4 the lambda, right. So, lambda is equal to 0.1 Pg1 plus 41, right. This is that cost characteristic is given, the DC sorry incremental cost characteristic is given, that lambda is equal to 0.18 Pg1 plus 41. Also second one is for lambda is equal to 0.36 Pg2 plus 32, because between this limit, between this your 46.76 and 73.4 they will work on equal lambda basis, right. That is why here also lambda is equal to this one, here also lambda equal to this one. This is I am taking equation 4, equation 5, right. Now, what you do, this equation you multiply by 2, this equation, that is 2 into equation 4, this one plus that equation 5, right. So, then you what you will get, 2 lambda plus lambda, 3 lambda 0.36 Pg1 plus 82 plus 0.36 Pg2 plus 32. You will get 3 lambda is equal to this one, that is equation 6 we are making, but Pg1 plus Pg2 is the total load PL, right. Loss is ignored here, later we will see the loss. So, Pg1 plus Pg2 is equal to PL, therefore, here you put substitute Pg1 plus Pg2 is equal to PL. If you substitute here, right, then what you will get, if you substitute and then just hold on, and then you divide, this is substitute and divide by 3, because this side is 3 lambda. So, substitute by and divide by 3. So, you will get lambda is equal to 0.12 PL plus 38, this is equation 8, right. Now, when lambda is equal to 73.4, because this is that last value 73.4, this is the last one, right, for this, because the maximum value for IC unit 1, right. So, in that case you will get PL is equal to 295 megawatt, right. So, if PL is equal to 295 megawatt, therefore, load range will be in between 73 and 295, because previously we have seen that your whatever this thing, previously we have seen that it was between 54 and 73. Now, beyond that, right, it will be your load range will be in between your 73 and 295, but let me tell you, here it is maximum is 180 megawatt for your Pg1, right. That means what will be Pg2? Pg2 will be 115 megawatt, because up to this it has gone 73.4. So, it is maximum is 180 and PL is maximum had gone in this range, in between this your what you call this lambda values in between 46.76 and 73.4, that is your load is 195, but it has touched the limit 180 megawatt. So, the generation of Pg2 will be your 295 minus 180, so 115 megawatt. Later I have put it in tabular form, right. Now, beyond this point only generator 2, after this if further lambda is increased, this has touched its limit. So, it will be kept fixed at 180 megawatt, it will be kept fixed at 180 megawatt, right, and after that lambda has increased, right. So, now only this rest of the load will be taken by this unit 2, generator 2, right. Therefore, and that will go from point say your lambda is equal to 73.4 to 78.8, right. So, in this case this is the lambda for the unit 2, 0.36 Pg2 plus 32, that is say equation 9, right. But when it touches the limit Pg2, that is a maximum Pg2, that is your 130 megawatt, right, this Pg2 130 megawatt. So, in this case that means in this case what will happen, Pg2 plus Pg1 max will be total PL, because at that time your this has reached 180 megawatt, therefore, Pg2 plus Pg1 max will be PL. So, Pg2 will be PL minus Pg1 max, that is equal to PL minus 180, right. This Pg2 is equal to PL minus 180, you substitute in that equation, right. Your just hold on, here you substitute Pg2 is equal to your this thing PL minus 180, you substitute here, because 180 is fixed now for unit 1. Therefore, you will get lambda is equal to 0.36 PL minus 32.8. Therefore, the load range will be in between 295 and 310, because maximum is load is 10, right. So, if you add 180 plus your 130, this will become 310, right, and but it will be, and that means in between load 295 and 310, that means this last 15 megawatt, that this your what you call this generator 2 has to supply, right. So, that means if we I mean the your that, and this is the lambda, this is the relationship between lambda and the load. That means, if we summarize this, then this one for load in between 54 and 73, right, megawatt. I have not written everywhere megawatt, understandable. Lambda equation will be 0.36 PL plus 20.48. For in between load 73 and 295 megawatt, lambda will be 0.12 PL plus 38, and in between 295 and this one, lambda will be 0.36 PL, your minus 32 point your this thing what you call 80, right. So, that will be, this is this one, right, this one. That means, first you have to draw these ICs. I told you how to make it, right, and accordingly you have to see that PG1 32 and your what you call PG2 22 megawatt accordingly, right. So, you have to see till it 46.76 comes, right. So, PG2 has to take care of this load, right, and because unless and until it comes, after that equal lambda basis. So, these two graph will draw, and step by step from for example 39 to 0.92 to 46.76, right. Then up from here to here 2 units will work till it comes its maximum value 73.4, and this one, after that another unit is there. So, up beyond that only this unit 2 will only work, right. So, accordingly you will just substitute and put those and get those equations, I mean lambda versus total load, right. Therefore, if we I hope you have understood, right. I hope you have understood. If you have any problem, you can write to me, I will explain, but have listen to this little bit minutely and try to solve of your own, then things will be better, right. Look at it and then see that how things are, right. Now, if you just make in a tabular form, for lambda is equal to 39.92, Pg1 is fixed. Look at this diagram, that Pg1 is fixed, right, because it is a 32 megawatt, unless because this unit has to generate your generation up to it comes 46.76. So, it is lambda 39.2, Pg1 is fixed, is minimum limit 32, Pg2 22, so 54, that is okay. Now, when it comes to lambda is equal to 42, Pg1 will remain fixed, but Pg2 has to generate power, because lambda from here you are increasing unless and until it comes 46.76, that Pg2, that your what you call this generator 1, it cannot generate take that one, right. So, that is why that when lambda is equal to 42, it is Pg1 will remain at 32, but Pg2 at that time calculate 27.78, all these equations have been given, right, and total will be 59.78. When it will come 46.76, Pg1 will remain at 32, at that time Pg2 is 41, that means at that time Pg2 is 41, right, for lambda is equal to 46.76, right, and total is 73. Similarly, when lambda 50, 70, 73.4, up to that limit I have come, that is 73.4, that Pg1 50, Pg2 50, it is 100, right, and when it is 70, 161.1, 105.55, 266.66 total PL is equal to Pg1 plus Pg2. When it comes up to 73.4, Pg1 fixed, and then 115 Pg2, total 295. Now, when it beyond that unit 2 only will take the care of this load further increase, till it reaches its maximum limit. So, that is why 75, 77, 78.8, 3 values I have taken, right. So, Pg1 is fixed because it has touched its limit. So, Pg1 is 180, 180, 180, and then only Pg2 you have to calculate 119.44, 125 and 78.8 is 130, total is 310. So, 299.44 at 75 lambda, when lambda 77 305, and when it is your what you call 310, right, total, right. So, Pg2 is reaching the maximum 130, it is 310. So, this way table I have made it for you, so that things will be understanding, right. So, this only 2 units have been taken. If you take 3 units like this, it is difficult to solve, as far as a calculator and this thing concerned. So, at that time we will go for some iterative technique, right. But this graph, whatever you if you have understood, right, then things are all right. So, best is this is IC2, repeating IC2 is taking the load, right, whatever increase it is, but Pg1 will remain at fixed till it comes to 46.76, right. After that IC1 will take up along with IC2 with equal lambda basis, still it reaches 73.4, right, that is maximum. After that if further increase, IC2 will take, right. Thank you, welcome.